Yeah, we had to emulate this force plate, and then for our group, we're also emulating the balance mat. So.
Did you guys already do like some research, like
Yeah.
So you know, like what kind of, there's like different types of force plates. There's some that use kind of like crystals in order to generate or to kind of like change the force that you're producing and actually run it through the force plate and into the system. And then there's this one that's more of a compression, and it kind of reads that compression and turns it into the force, and then it reads it. So
Yeah.
that's the one that this one uses. So that's kind of the one that you guys will be trying to recreate.
Yeah, so I think this one uses strain gauges or, yeah.
Yeah, so that one's a little, it's still accurate, it's still one of the more accurate ones, but it does lose a little bit of that energy in order to convert it into the force. But this one's pretty good with that. And then you also have the other one that uses more of the crystals and kind of that compression still, but it's more direct.
Yeah,
So
I know what you're talking about.
Yeah, so that one, so that's pretty much what it works. So pretty much what this one reads, it's going to read the forces in all directions. So in the Z direction diagonally, in the Y direction, up and down, in the X direction going side to side. So it's going to read all those directions, going to give you all that when you actually do read it, especially the embedded ones, but I'm pretty sure you guys are more, you'd be more focused on the portable one.
Yeah. Do you guys prefer the load cell ones, which is this one, or the more piezoelectric ones, which produce its own electric current to output?
We don't really mind whichever one. We do like the piezoelectric one just because they're a little more accurate, or they're a little bit more direct.
Oh, is that it?
So it's a little bit more instantaneous.
Oh, okay.
Oh no, this one isn't it. This
I was
one's
about to say,
it's the same company.
Okay.
But the other ones would be better. They're a little bit more expensive.
Yeah.
But they are better just because it's more instant.
Yeah.
And
Oh.
it's more accurate. This one, it does take a little bit of time. It has to wait for some type of movement, and then it starts to read. Because it has to get that compression, then read that pressure, and then turn it into the force, and just read everything. But yeah, this one also reads jump height. So it just calculates the amount of time that you spend up in the air and the amount of time that it takes you to get back down.
Yeah.
So it just calculates it that way. It calculates velocity the same way. It calculates power, force, ground reaction forces. What else? It calculates the rate of force development, so just how long it takes you to develop that force. Yeah, that's pretty much like everything that.
What was the name of the company?
AMTI.
AMTI.
Yeah.
Yeah. That's right there. So it comes with software already, correct?
Yeah, it comes with software that you can just put into whatever computer. You just have to make sure that it's a computer that has a pretty good what's it called? Processor, just so that it can handle all the information. Just because it can crash, just from like all the information that's in you getting at once. So that's going to just pull it up really fast. Do you guys want to see how it feels? You guys want to try it out?
Oh yeah, yeah. We will want to see some sample.
Data or something.
Yeah. Exactly. I think we could do it better.
Alright, so who wants to be Joe Schmo?
I have to record it, so someone else has to do it.
And then you just have different types of movement that you can read. So you can be doing the single counter movement jump, which is the one that we're going to do right now. Just because it's the easiest one. We can also do an isometric lift, which is what we do for like certain studies. Then we can just do a bunch of different tests, just that it takes into account those different circumstances and then applies the force.
Okay. So do these change the output at all? Is there more of just a label?
It's more of a label just to know what kind of movement you're doing in order to produce that.
Okay.
In order to get all these different variables.
So this is just a standard jump then?
This one, right?
Yeah.
Or this category, this kind of single counter movement jump.
So yeah, so that's what we're going to be doing right now.
Yeah, so a single counter movement jump is just what you normally do whenever you jump. So when someone tells you to jump, a counter movement jump is just gonna right away as soon as you shorten up the muscles, then you're gonna extend them and then you're gonna jump.
Okay, so that's this whole movement here. Okay. And then, do you happen to know what the red and then the black line underneath it as well is?
And these are just the different forces. So these are just the forces in different directions.
Oh, okay.
Yeah, but the one that we're usually looking at the most is gonna be
in the Z direction.
Just because it's gonna combine both the movements, which is where you're gonna be moving both down and then back up.
Got it.
Yeah, and then you can just look at all the different graphs for the velocity, power, peak power, look at the bar graphs, the rate of power development, the work, power. So this kind of just tells you like kind of where that power is being distributed. The jump height, so just in general, and then it gives you a summary of each different variable.
No, does this software like
Mhm.
come with the force plate, or is
Yeah.
it?
Usually the company does provide it, or at least provides you with the one that would be most compatible.
Oh, okay.
Mm.
Is there anything else that you have to put in for like the user other than like the type of? Oh,
No, so pretty much it's just all this, and then you have to zero it out and then weigh the athlete separately, just because it's gonna obviously the forces are gonna be different depending on how much
Weight.
the athlete weighs.
So this doesn't weigh it. Does
It
this
does
weigh the
weigh it.
Oh, okay. You just
but
have to do it separately.
also
as
weighs
a
it in newtons, so then you could just convert that to kilograms
Okay.
if you ever needed that. But yeah, that's pretty much just how it calculates everything, and all this stuff doesn't really matter. There's more. All this right here, like the group name athlete, that's more for research purposes. So just
Okay.
so we can have it and file them and
Make
make
this
sure
a-
we can go back to them later. But we don't have to put any of this stuff. We can literally just go into the test. The only thing you have to do is that you have to connect it. So we just have to like connect the device to the computer so then it can read everything. And then once you do that, then you just set it all up. Make sure you have like what movement you're going to be doing, just so you know what you're actually measuring. Zero the device, just so there's not going to be any excess weight. And also you can zero it out with things on it. Just like for our study, we did an isometric mid-thigh pull, but we wanted them to have it at their mid-thigh.
Mhm.
So we had to put risers or just plates. So we just put the plates on there, zero it out, so that way it doesn't take into account the weights.
Okay.
But since we're just going to be doing the counter movement jump, and it's going to be a varied version, just so you guys don't like smack the roof. So pretty much you're just going to go back
That sounds.
and just like this. So
Okay.
don't like extend your hands all the way up, just kind of like
Okay.
keep them right about a little bit above your chest.
Got it. So
Yeah,
who's gonna be
whoever
doing
wants
it?
to try
Whoever
it.
doesn't mind being recorded.
Some stuff on just yet. Go ahead and hold it a second. Alright, go ahead and step on. Maybe like right in the center.
Does it give a live
And
reading?
facing the wall.
No. Sorry.
And just stand still. There you go. And yeah, you're not gonna be able to see. It's not gonna be like if you were looking at muscle activity. So
Okay.
it's just gonna wait until the test finishes, and then it's gonna give you all of that.
Okay.
So I don't know if you guys could create like a live version where it's looking at the forces while he's just standing there, and then as he does every movement, he's gonna start moving the graph and just show you everything. Alright, so do you need any explanation for the test again? You just
should I
kind of
just
move
go
it down,
down and then
just go up, and just like keep your hands about here, just so you don't like smack the roof right there.
Should I go for it?
So give me 1 second. So right now, she's gonna wait until you move. So I was gonna say whenever you're ready,
Okay.
then just go ahead and jump. So get ready and jump. That was more like a high knees than a
Should
high
I-
movement jump, but it's still gonna.
Doing high knees.
So the high knees is
Uh-huh.
it's more because you are exerting more pressure, but you're not really moving up. Your body's kind of staying in the same place. Your legs are just
Oh, okay.
kind of coming
I
up.
think he doesn't want to hit the ceiling.
I don't think. I think
doubt
your
I
head-
could hit the
I
ceiling.
don't think your head would. We have some pretty. Even the tall people.
Yeah.
It's pretty hard for them to touch the ceiling because that when you extend your hands, it does help you kind of move your
Okay.
body a little bit farther up. So when you keep them here, it kind of like limits your height. But that one will still give you a reading, so it's kind of going to show you. So you can see right here, this is kind of where you started to jump up. You came down, so all your weight went down, and then you jumped. So it's going to be all the peak forces that you're going to be actually producing.
Okay.
And your velocities for racing, the power.
Pretty
Peak
impressive,
power.
right? And so then that's just the summary. So the calculations didn't take too long.
No.
But it just crashes sometimes.
More so when there's like when we disconnect things improperly. So if we like shut down the system, close the computer, and then we're like, oh damn, we left the USB in there, and then we plug it out, that kind of messes up
Oh,
the sync
okay.
with both the force plate and then all the software.
Okay.
What if I get a picture of
That's
the
okay.
line of the graph?
Which one?
The graph?
Just all the graphs, or just the like? Are you guys focused on any types of variables? Or just
So
wanna get,
we're
like, a
just
general?
we're trying to mimic pretty much this, but a more portable,
Yeah.
affordable version of it. So pretty much we're focused on emulating everything.
Did you guys look at the cheaper versions?
Yeah, I think they would come up to what $300-400.
There's even some that are like $100. They're
Mhm.
more for like
Just like
high
basic
schools,
version.
middle schools, just for like coaches that want to look at like certain like push off forces or
Mhm.
just push off speeds for like soccer runners, pitchers, anything like that. So they make cheaper ones, but obviously like I don't know how accurate they are compared
Yeah.
to like the more expensive ones.
They said as long as within 20%, it should be fine.
Yeah, so I think.
So what's the maximum amount of Well, like how strong and powerful can the jumps be? Like what's
Oh, it
the
can be
highest
as
you've
strong
seen
as
it?
it can. I mean,
Okay.
we've seen anywhere from forces up to like 3,000.
Okay.
So 3,000 newtons.
So up 3,000 is usually the peak.
It's not the peak for the software. That's just like our
The peak,
own.
yeah,
Like
yeah.
our own. And obviously we don't train like, or we don't test super high athletes like Olympic
Yeah.
Olympic athletes or professional athletes. It's more
Track
collegiate
2000.
athletes, which even
Yeah,
though they're
track 2000.
pretty good with what they do,
Track 2000.
there's still a limit to what they can do like physically.
Okay.
Maybe if we had like people that are, especially with the movements that we do, no one really trains
Mhm.
with these movements, so they're not really movement specific. It's more activity specific.
Mhm.
So they're actually focused on like actually doing the movements, pitching, playing tennis, playing basketball.
Okay.
X, Y, and Z.
But this one just gives you like
On
an
the same graph.
idea
Yeah.
of how much force they can produce. Alright, so you want to try it again with like the
Yeah,
number? Alright, so it's still calibrated to your weight, so you don't have to like reweigh anything. Alright, so just like I said, you're just gonna go up. Make sure you actually jump, so you're gonna kind of try to push off your toes instead of tucking in. So just push up, extend, and when you land, bend your knees. Alright, whenever you're ready. There you go. So the last one, you got I think like 1,600 for your force. So let's see if it changed anything from just changing your movement. So yeah, so you got 1,600 for your last one, now you got 1,700.
Okay.
Because you were actually pushing off instead of kind of just tucking in.
Yeah.
So, a little bit- so just like depending on the movement, so when you guys, I mean, I don't know if you guys are more worried about just creating it or creating it for any specific purpose? Or like any settings?
They told us just to emulate.
Just make it.
Yeah, just make it.
Just make
So
it,
and
make
then.
it. Alright.
Um,
Yeah, like I don't know if you guys want to make it
So what's like the
specific.
primary function that you guys use this for? Like is it just like to measure athletes' jump
Yeah,
power? Or?
for mostly for jump power is the best one, but you can also, like I said, you can use it for other settings. So you can like put it on a mound, and it'll still read the forces going through whatever
Yeah.
whatever you're gonna be putting on it, and then you can just measure different movements. So if you tilted it a little bit forward, then you press start, and you kind of had a runner just like in the starting position. And
Oh,
then
you
you
can
can just
do that.
measure off the like the pushing forces.
Okay,
Or
so
you
it doesn't
can-
have to be on a completely flat surface.
No, it
Surface.
doesn't have to be NFL. That's kind of like why it's so a lot more preferred than the
Yeah.
embedded one. Because the embedded one, obviously, if you want to test running, you can because you have like all the 3D cameras. You can put the
Oh, so that's what
EMGs
those
on
are.
them. Oh yeah, yeah. So these are just like cameras that we put like little what's it called, like
Tracking cars, like little IR
not the
trackers.
track, but like what do they call it? Like when they make like the video games and they kind of track like the movements for.
Yeah, like the tracking balls, right?
Yeah.
Yeah. Oh, like the reflectors. They're pretty much like reflectors that just like reflect the light, because that's what it's picking up. It's just picking up like a little reflecting light and just copying or emulating like the movement that's being produced. But you can put all those on, and then you can test the gait, running gait, walking gait.
Mhm.
But there's not a lot of space. So
Yeah.
that's like the limit for the embedded one, is that if you embed it in a small room, you can do very dynamic movements. But you can also
Yeah.
put these on a track. So you can put them on a track, and then you can do a little bit more
Yeah.
full-on moves. But they need to buy the same company. Yeah, yeah, it's the same one. This is that one's embedded, and this is just more portable. And obviously a little more bulky, but you can do a lot more with it.
So this is definitely the more preferred method then.
Yeah, or if you want to do, you can do a wider range of things. So you can still use the 3D cameras with this one, but then you just have to know where you're gonna put the 3D cameras.
Oh, okay.
So you can put them in a bigger room. You can put them in a wider room just so you can do more or farther movements. It just depends how you're gonna use the equipment.
Do you know how much this one
Yeah.
costs?
Yeah.
around-
Yeah, I did, but I'll take a picture of it again.
Yeah,
and we're gonna
like anywhere from like 50 to 100
tie later on
In
it.
terms of like,
Oh yeah, you got these results.
Yeah.
You didn't get any stronger.
Yeah, for the body composition.
Yeah, they're pretty much.
That's how you
We'll be able to.
Because they measure a lot of things and a lot of athletes and a lot of
And you still got weaker.
want that kind of information. They want to know how their athletes are doing.
Yeah.
They want to get precise information. So yeah, they like coming here and doing a lot of the testing just so they know if their athletes are actually improving or if their workout programs are trash.
in terms of like sizing of the plate, have you guys ever had anyone like jump off of it? It seems like it's pretty
That's why
huge.
you can. Yeah, you can. Even though it's big, no one jumps on a platform. Like it's very unfamiliar. So we do whenever we do testing and stuff that we want to get really accurate, we do familiarization. So just like, hey, get a feel for it. Don't be scared. You're not gonna jump off of it. It's very unlikely unless you're jumping really wrong and you're
Yeah.
like jumping
Off to
out
the
or
side.
jumping forward. But once they get used to it, yeah, it's just like they're jumping on a normal surface.
Okay, so you've never really had anyone like fall off when
No.
they're jumping. It's never been.
Not fall off, more so just underperform because they're scared of that.
Okay.
So they get ready to jump, but once they're about to jump, they kind of like do a little baby jump, and they're like, "I'm sorry," like it just felt really weird. But then once they do like a normal one, then they're like, "Okay, it wasn't that bad," and then they get used to it.
By any chance, do you have anything to measure like the exact like height of the plate, like a ruler or anything, just so we know?
Yeah.
Uh,
Because we guys put different dimensions.
Did he open the application or once he put in the application?
I think just opened it manually, so it's like something that's included in
It's
the
separate. It's not preloaded into the force plate.
So just the height, or do you want to get like the whole?
I guess all the dimensions would be even better.
So it's about 5 inches tall. About 40 inches long. And 30 inches wide.
Is it okay if I just click through the different tabs? Is it okay if I just
Oh,
click
for the
through?
first game,
Okay, just so I can like actually have everything. So this is the graph.
Oh, you want to get in there? You see everything? Are you guys all in the same program?
Oh, is this the same?
I think you get two
I don't know.
groups.
Yeah, this is
Oh, okay.
Three?
There's three groups?
There's three, but.
There's 3 groups.
Balancing, I think.
Yeah.
Oh, just balance?
Yeah.
Oh.
Can you take it out to, I don't know, they said that you guys have to move it outside of it.
Yeah, so just like I said, like with the different movements, especially for jump height, we want to get an accurate reading, so we just move it to a taller space.
Oh, that's
So it's all
interesting.
portable, so you just
What is it?
unplug it, just needs a
The distribution of force on the plate.
COP.
Yeah, that's it. They
So,
can- they can
I was
do it.
wondering if you do that or not. because-
We haven't done that, like I haven't done that, but we've just moved it around, like we put it in the stadium for like different classes.
Okay.
And we do it for like testing, so just like anyone that wants to participate in the test and is able to participate.
Okay, I think that's pretty much it, right?
These are what we're probably gonna mainly
Told me
focus
that
on,
it's
right?
like HI
Yeah, so this is, so it's mainly the summary,
And then
and this, and the graph is what we want to
We can do
put
a bunch
output
of
to the
different
app,
tests on it, but
and
it wouldn't
then,
take more than a minute.
if they want like
Test, maybe less.
more,
If
we can do
different
tabs,
movements
like
or
they do this on the app, or this on the side,
fast.
you know, like a menu pop out.
On average,
That
like,
seems
how many
fine.
tests do you do on, like, a
And then
like,
the summary will be the first one, and you could click on each one to get the graph for it, which would probably be what we should do. Yeah, I think that's actually what's
there's
best.
these options here. We have the name, the group
Yeah,
name.
I recorded the whole page, so yeah.
They have different tests.
I'm just gonna take pictures of it.
Just go down on this.
Oh yeah, we should get. So these are all the different types of jumps. Yeah, I asked them. He said they're just
Are there, like,
labels
some
mainly.
points that you would have if, like, for people that use it or anything that, like.
The outputs are still the same. There's more labeling. And then obviously 0 body weight and all that. Oh, it measures the body weight in newtons. Okay.
Making it a different, maybe making like different attachment surfaces, just so it kind of blends in with whatever you're already on, so you're not really focused like this is a completely different surface than this surface. So just have like maybe the same color. If you're on turf, have a little turf that you can slap on there. Just something so they're not like focused that it's such a different space.
Oh, so that's actually a big issue with some
Yeah, just like
athletes.
not really a big issue.
They're
but just,
intimidated by
yeah,
it?
they're just like it just feels weird knowing
Having-
that they're like on a taller surface than the floor, even though it's only like 6 inches. So.
Yeah. Okay, that makes sense.
And I don't know if you guys could do some sort of like a battery cell or something where you don't have to plug it into a source, but that's something like some
You
of the
have to plug
issues.
this into the wall?
That's some of the issues we have too. Is like if there's no source and we don't have a long enough extension cord, then we're limited to where we can put it.
That'll definitely be implemented.
I think you guys can do that.
Yeah.
Maybe making it Bluetooth compatible. I don't
That's
know.
exactly.
Yeah.
That's exactly what we're planning. We're
Yeah, like, that'd be
planning on
really
making a phone app, so this way you don't need a computer.
Read all that on your phone, hopefully.
Yeah, that'd be really helpful, because I know we have for the timing gates. Now it's more Bluetooth compatible, so we just set it up to like an external Wi-Fi that it comes with like a little red box.
Nice.
And then we just set that up with the program, and then it just runs everything. So we still have the timing gates. That's the only physical part that we still have, but everything else just on an iPad. We run it, and then can do all the tests. So if you guys can do that with this, that'd be cool.
Scott, how many software programs do you have for this stuff?
This one's just one.
Just one right here.
The Biodex, it has its own embedded program in there.
So does the track.
We'll have to look at this
I'm
next.
just wondering if there's any software.
I don't. It's gonna be really hard to implement.
Yeah, like this
Wait,
one.
actually, we're trying to make something original, and then we're like, oh, you guys do this.
No.
It looks pretty stupid.
So I think it moves. It has to move around so that you can test your balance. But for us, we're just worried if you're standing on it, it tells you your center balance. That's it.
Yeah.
So yeah, I mean the AccuPower.
Because that's all we're gonna do. We're not emulating this entire system. It's more of like an extra feature to that. Okay. Well, I don't know if you guys have any more questions for
For the force plate?
force plate.
Not immediately. If you want to continue with the balance.
Yeah.
Or we just look at it.